Linear forms, graphing linear forms. This topic brings together our graphing technique for all three special forms of linear equations. First, we have slope-intercept form, y equals 2x. So in this equation, we can see that, remember, slope-intercept form is y equals mx plus b. So in this case, our plus b is plus 0. That tells me that my y-intercept is the point 0, 0 right there. All right. Now, my slope of 2, so my slope is 2 right here. So my slope is 2. Remember, slope is delta y over delta x. In this case, it's 2, which is 2 over 1. So this says to go up 2 to the right 1, delta y over delta x. Right. Up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Or similarly, that could equal negative 2 over negative 1, which says to go down 2 and to the left 1, down 2 and to the left 1. Now, once I have those dots, I can connect those with a nice straight line, well, as straight as I'm able to. With the dots there, it doesn't so much matter whether or not I get it perfectly there. Graph 2, y equals mx plus b. So my b there is negative 1, so that tells me that I can put my y-intercept 0, negative 1 right there. My slope is negative 3/4. And so negative 3/4, so this is my slope. Negative 3/4 is negative 3 over negative 4, negative 3 over positive 4, or 3 over negative 4, either one of those. So this says to go down 3 and to the right 4. Down 3 and to the right 4. So down 3 and to the right 4. And I can't go down 3 and to the right 4 any farther because I'll be off the graph. This one says to go up 3 and to the left 4. So up 3 and to the left 4. And similarly, I'll go off the graph if I go any further. So on this one, my graph is going to look like, whoops, that's too big. It's going to look like that. All right. Here, this is in point slope form. Here, my slope is negative 1. My point is going to be from those right there. The point is going to be negative 2, positive 3, negative 2, positive 3, with a slope of negative 1. So my slope of negative 1 tells me to go down 1 and to the right 1, or up 1 and to the left 1. Either one of those makes sense here. Down 1 and to the right 1, up 1 to the left 1. Connect those. So point slope form. Start with the point and use the slope to find the rest of them. Here, my slope is the 2/5, and the point is going to be the point 4, negative 3. 4, negative 3. And the slope is 2/5, or negative 2 over negative 5. This says go up 2 to the right 5. This says go down 2 to the left 5. I can't go up 2 and to the right 5 from my red point there. It would take me off the graph. So I go up 2 and to the left 5. Up 2 and to the left 5. And I can connect those with a line like that. I guess it might be important. I should have said, remember that with the point slope form, it is y minus y1 equals m times the quantity x minus x1. So that's the general form of the point slope form. So you can see how it relates to those two, and especially with the point. So here the point is -2, +3, -2, +3. Here the point is +4, -3, +4, -3. Standard form is ax plus by equals c. And here, the thing that we're going to do is we're going to find our x and y intercepts. So first, I'm going to find my x-intercept by plugging in 0 for the y value. That will put the point on the x-axis when I plug in 0 for the y value. So I have 2x plus 3 times 0 equals 9. This 3 times 0, that's 0. So I have 2x equals 9. And then I divide by 2, and I get x equals 4.5. Should have written a little bit smaller here to make sure I have space. This gives me the point 4.50 right there. The next thing I'm going to do is find the y-intercept by plugging in 0 for x. So 2 times 0 plus 3y equals 9. Again, anything times 0 is 0. So I have 3y equals 9. Dividing by 3, I get y is equal to 3. And that gives me the point 0, 3. 0, 3 right there. And now I can connect those 2 points with, let me see if I can get a little bit better, the 0, 3. I can connect those 2 points. I could also notice that when from here I go down 3 and to the right 4.5. So I could go up 3 and to the left 4.5, right? Whoops, up 3 and to the left 4.5 and get another point right there. So that might also be useful to add a point there. So that's just using the information from the one pair of points to find another point. But you don't have to do that if you don't want to. You could have just connected these 2 points and you still would have gone through that point if you had a nice straight line. So again, we're going to find our x and y intercepts. So my x-intercept I get by plugging in 0 for y. So I have 3x minus 4 times 0 equals 0. This makes a 0. That's why this finding the x and the y intercepts is so easy here. 3x equals 0, divided by 3, x equals 0. So that's the point 0, 0. And for my y-intercept, I have 3 times 0 minus 4 times y equals 0. So -4y equals 0. Divide by -4, and I get y equals 0. So that goes right on top. So, oh, whoops, here I added the point 0, 0, and here I also have the point 0, 0. So this is an unusual situation where I can't really graph because my x and my y intercept are both at 0, 0. So what I need to do is solve for y by by subtracting 3x from both sides, and I'll get negative 4y is equal to negative 3x. And then I divide by negative 4, and I get y is equal to 3/4 x. So that tells me I go up 3 and to the right 4 to find another point. Up 3 and to the right 4, or down 3 and to the left 4, and connect those up. And there is my graph. That last one was a little tricky.